In previous videos, we've talked about the new ECM motor that is on the current furnaces on Carrier and Bryant. Over the years, we have used different models, the ECM 2.0, 2.3, 2.5, and 3.0. In this video, we'll talk about troubleshooting these ECM motors. Between the 2.3 and 2.5 motor and the 3.0, there have been a couple changes in the plugs. The high voltage has always remained a 5-pin connection, and on the communication line it has gone from a 16-pin on the 2.3 and 2.5 to a 4-pin connection on 3.0. In order to correctly troubleshoot these ECM motors, you have to have the troubleshooting guide that gives you the voltages that you're supposed to see on the communication line. These troubleshooting guides are readily available on the Carrier TechLit app and the Bryant TechLit app. So in these troubleshooting guides, you have the various status codes, fault codes that will be shown on the thermostat or flashing on the furnace control board. This particular code 42 is an inducer motor fault, which is a ECM motor. You will have steps that they want you to go through to try to determine what the problem is, and by answering yes or no, they direct you to the particular step that you need to be checking. In step 18, you will notice that you are checking the inducer pulse width modulating line. And so between the brown and the yellow wire, when the motor is off, you should have 2 to 5 volts DC. And when it's calling for the motor to run, you should have 9 to 13 volts DC. So you see, it's very important to have these voltages so you know whether the board is putting the correct voltage out to the motor through the harness, or if the motor is not receiving it and it's a defective motor itself. So in this step 35, we are being told to check the RPM feedback line. Some ECM motors have this feedback line where the motor is telling the board what it is actually doing. So between the brown and orange wire on this motor, when the motor is off, you should read 15 to 17 volts DC. And when it's commanded to run, you should read 12 to 14 volts DC. On this page of the troubleshooting guide, we have status code 41, which is a blower motor fault. Whenever you're checking an ECM motor, you should of course first check that you have your line voltage, either 115 or 208, 230. ECM motors will be powered continuously by high voltage. Then it directs us to check the 12 volt DC supply between the red and the green terminals. So this is a graphic of what our troubleshooting guide is showing us, and here we're checking an inducer motor, and we're checking the pulse width line from the board to the inducer motor. On the off cycle, we should have very little DC voltage of 0.1. When the inducer is commanded in low speed, you should have 6 to 7 volts DC, and at high speed, 10.5 to 11.5 DC between the brown and the yellow wire. Then this inducer motor has a feedback line to tell the board what the RPMs it is running at. So in the off cycle, you should have 11.5 to 12.5 DC, low 10.2 to 11.2 volts DC, and high 8.4 to 9.4 DC. Here we have a graphic of one of the newer motors that has a 4-pin connection for the communication. And you'll notice that between the blue and the green, you should have 0 volts DC, and that will pulse with the serial output signal as the motor is commanded to run. Then you have a 5 volt DC stable serial input between the yellow and the green. And then you have the 12 volts DC supply voltage that is constant between the green and the red. So when you're checking these voltages, you want to make sure that you double check at the board itself to make sure that the board is putting out the correct voltage as outlined in the troubleshooting guide. You want to also make sure that the voltages are getting through the harness. Many times the harness is the problem. There's a broken wire or a pin that is not making connection through the connector pins in the harness. And then you want to check at the pin on the motor itself to see if the voltages are getting to the motor through the harness. If they are, and the motor's still not running, then that means that you have a bad motor. When working with these ECM motors, you want to make sure that the dip switches that are on the control board are set correctly. There are charts like these in the installation guides for either the furnace or the air handler, which tell you what you can set the dip switches at for various operating modes. On the furnace or the air handler, you will also have dip switches where you can set up the AC and the constant fan airflow selection. Make sure you set these correctly for the tonnage equipment that you're working with. Keep in mind that if your system is on a Carrier Infinity or Bryant Evolution thermostat, the dip switches will be overridden by the thermostat. So any airflow changes that you need to make, you will need to make it on the stat and not the dip switches. For further information on ECM motors, a great resource is www.thedealertoolbox.com.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.